For the first time since the 3I Atlas was detected screaming into our solar system, scientists are no longer just arguing about speed, trajectory, or reflection patterns. They're arguing about shape, and what they've just seen has shifted the entire conversation. Because in the newest ultra-deep composite image, what astronomers are now calling the mega image, there are structures, not random noise, not lens flare, not processing artifacts, structures. When the image first dropped internally, many assumed it would be another incremental update. Slightly sharper tail, better coma detail, maybe clearer dust streamlines. But what they saw instead made several researchers pause mid-analysis, not because it was beautiful, but because it didn't look natural. The observation came from a stacked image created using multiple exposures taken across different filters and wavelengths, a technique normally used to cancel out visual interference and sharpen blurry, fast-moving objects. In theory, this should make the image more boring, more predictable. Instead, it did the opposite. Inside the diffuse glow of 3I Atlas, where scientists expected a messy cloud of gases and ice vapors, appeared defined geometric patterns. Subtle, not cartoonish or obvious, but consistent enough across frames that they couldn't be dismissed. Linear shadow bands, arc-like structures, regions of unusual uniform curvature where there should have been chaos. These weren't dramatic sci-fi shapes. They didn't scream spaceship. They whispered something more unsettling, organized irregularity, and that's often more disturbing, because chaos has rules in nature. Randomness follows patterns, and those patterns weren't matching anything we normally see in comets or interstellar visitors. At first, they suspected data corruption, a misaligned tracking vector, a timing offset in the telescope's motion compensation. But frame after frame showed the same anomalies, the same patterns, the same strangely symmetrical distortions within the core brightness region. This wasn't just one telescope either. It wasn't one lab. It wasn't even one country. Observatories in Europe and South America received the raw data and independently confirmed that something structured was present. No one's calling it a structure yet, but no one's calling it noise anymore either. And this is where the story changes. Because until now, 3I Atlas had been treated like a fast, strange comet, an interstellar drifter, possibly unusual, possibly rare, but ultimately natural. Now, scientists are forced to ask a different question. If this is just frozen junk from another star system, why does it show organized morphology under deep imaging? Some astrophysicists have suggested it could be layered materials reacting differently to solar radiation, similar to when different materials weather differently on asteroids. Others argue it might be a rotational phenomenon, some extremely rare spin configuration causing dust jets to align into structured patterns. But here's the problem. Those explanations don't fully explain the repeated geometric consistency, because random outgassing doesn't create controlled curvature, and rotational turbulence doesn't sustain ordered symmetry for multiple observation sequences. Nature is messy, especially at these scales. 3I Atlas isn't. And that's what's making this unsettling rather than exciting. Most scientific discoveries inspire awe. This one is generating unease. One researcher famously said during a private call, "It's like looking at a storm cloud and seeing straight edges." And that's a perfect way to put it, because storms don't do straight lines. They smear, they bleed, they distort. This didn't. In the sharpest version of the mega image, a faint stripe-like feature appears embedded diagonally inside the coma, not aligned with the tail, not aligned with solar wind direction. Just there. And it stays there, across different exposures. Some describe it as an internal ridge. Others call it a brightness discontinuity. A few have quietly used the word framework. But cautiously, always cautiously, because nobody wants to be the one who jumps too far. Not yet. However, silence hasn't stopped speculation outside official circles. A growing number of independent analysts have started digging through the pixel data themselves, not with YouTube Photoshop overlays, not with AI enhancement filters, but by analyzing light intensity gradients, contrast anomalies, and edge behavior across different frames. And they're finding patterns that keep repeating: small curved segments, symmetrical alignments, substructure inside the coma. Again, not definitive evidence of anything artificial, but also not easily dismissed anymore. What's interesting is that NASA hasn't officially commented on the structural anomalies themselves. Instead, they're calling it complex internal morphology, a phrase that sounds boring enough to dismiss, but vague enough to cover something uncomfortable. Because once words like structure start making rounds, control of the narrative becomes more important than the phenomenon itself. And they know this. They remember what happened with Oumuamua. Back then, confusion and mixed messaging allowed speculation to explode uncontrolled. With 3I Atlas, they're moving slower, more carefully, more controlled. But internally, a lot of scientists are clearly unsettled, especially because the mega image didn't just reveal shapes, it revealed stability. These formations aren't vanishing between frames. They're not randomly shifting, they're maintaining coherence. And in astrophysics, coherence is meaningful. It suggests structure embedded in the object, not just on its surface, which leads to much bigger questions. Because normal comets are structurally weak. They break apart, they fragment, they erode violently, but 3I Atlas seems preserved. Despite traveling through interstellar space for who knows how long, despite entry into a completely new star system, despite increasing solar radiation pressure. And that's where the uncomfortable thought creeps in. Preservation like that usually implies either extremely rare material composition or intentional design. Nobody's saying that second part out loud, but that's exactly what's causing the unease. Because the more data comes in, the more this object defies the typical degradation pattern of natural interstellar bodies. It's holding shape, holding pattern, holding something inside. And if this really is just a weird natural object, it would be one of the strangest nature has ever thrown at us. But if it isn't, then this isn't just a comet story anymore. It becomes a contact story. Not contact with beings, not contact with a signal, but contact with evidence. A relic, a messenger, a leftover from something older than our solar system. The reason scientists are tense isn't because they think it's an alien probe tomorrow. It's because this might prove we're not just finding rocks out there. We might be finding artifacts of other cosmic histories, other technologies, other extinct civilizations, or at least their debris. Imagine civilizations millions of years ahead of us, leaving structures that drift between stars long after they're gone. Not ships, not alive, just durable relics, like space fossils. And suddenly that's exactly what 3I Atlas could be. Not a spacecraft, but a fragment of something that once served a purpose. That's a much quieter idea, but much bigger too, because extinct intelligence is harder to comprehend than living intelligence. Living intelligence can be detected, communicated with, reacted to. Extinct intelligence, only studied, only interpreted, only guessed at. And interpretation is where fear grows. Right now, scientists are still in phase 1. Careful observation. They're collecting more data, more spectral images, more polarization studies. They're looking for heat inconsistencies, density layers, and magnetism anomalies. Because if it really is just a weird natural object, those will eventually line up. And if they don't, then they're left with something they don't have a category for. And when astronomy doesn't have a category, that's where revolutions begin. But here's the most chilling part. In multiple frames of the mega image, 698 in Mediaede, the strange formations appear slightly more defined when visible light filters are removed and near-infrared imaging is applied, which means these structures might not be just surface effects. They could be physical components, embedded elements, parts, not details. And that changes everything. Because if these formations persist and sharpen as we get closer, then 3I Atlas won't just be the first known object from another star system. It might become the first object that forces us to ask, what else is drifting between stars that we never realized wasn't just natural? And how many have already passed us, unnoticed? Because if we're just now seeing structure at this distance, how many did we miss when our telescopes were weaker? How many came and went unseen? 3. I Atlas might not be the beginning. It might just be the first one we finally noticed clearly enough to realize the universe might be filled with relics, and we've only just started looking closely enough to see them.